Okay, I'm back, and now we want to discuss how do earthquake waves travel. Another name for that is propagate. So how do earthquake waves uh, propagate after the ground has ruptured? So there are four main types of earthquake waves. Now there's actually more than that, but for what we need to talk about, four is going to be more than enough. So they fall into two categories. You've got body waves, which are going to travel through the body of the earth, and then you're going to have surface waves, which are going to require a surface. So the kind of surface waves that we're going to be concentrating on in here are going to be surface waves at the surface of the earth. However, it doesn't have to be that way. So what you're normally familiar with is like an ocean wave. So in an ocean wave, the ocean is doing this, and you have two different substances. So you've got the water, and then you got the air on top of it. So there's an interface between the two. So let's pretend that you're inside the earth and you have two different kinds of rocks. So maybe you've got limestone, and then on top of it is sandstone. Well, in between the two is going to be an interface. And so it is possible that when an earthquake occurs, the interface between the limestone and the sandstone can be doing this just like an ocean wave. So don't get the idea that surface waves have to be at the surface of the earth. But now, for the rest of the lesson, we are going to assume that they are. So there are two kinds of body waves. You've got the S waves, and then you got the P waves. So S wave stands for secondary, or you can think it stands for shear. So either of those would be okay. So to generate an S wave, what we're going to do is we're going to take a slinky and we're going to stretch it out. So I'm stretching it towards you, okay? And then what I'm going to do is I'm going to take the slinky and I'm going to move it up and down like this. And what that will do is it will generate a wave that is going to move towards you. So that is a S wave. But there's another way of generating an earthquake. So let's take our slinky. We're going to stretch it out like that. And this time I'm going to give it a shove. So when I give it a shove like that, then you're going to have a pulse that's going to travel. So you can think of P standing for primary, or you can think of P as standing for pulse. So it's going to be a pulse when you shove it, and that pulse is going to travel towards you. So in the pictures that you have there to the left, you can see what do these different kinds of waves do to telephone poles. All right, now let's look at the surface waves. And so there are two kinds of them. So L stands for love, and then R stands for Raleigh. So let's first look at those L waves, and you can see that what it's going to do is make the ground go back and forth like this. So the S waves were the ones that did this, and then the L waves are going to be the ones that are going to do this. And they actually cause the most amount of damage when an earthquake strikes. Okay, then you got Raleigh waves, and the Raleigh waves are very similar to the kinds of waves that you would have in the ocean. So the actual ground will go around in a circle, and water does the same thing in an ocean wave. So those are going to be called Raleigh waves. Okay, so let's let's summarize then what we've just said. So the four kinds that we've got are primary, S waves, love waves, and then Raleigh waves. Okay, the primary and the secondary are body waves. The L and the R waves are going to be surface waves. Okay, then the shape, so I've got a dot to represent primary, so it's moving towards you and away from you. Transverse is up and down. The love wave is also transverse, but it's sideways. and then the Raleigh wave is going to be circular. Okay, now the different kinds of earthquake waves travel at different speeds. So it turns out that primary waves are the fastest waves. So they travel through the earth the fastest. So that's why they're called primary waves. Secondary waves are the second fastest of the different kinds of earthquake waves, and so they are secondary waves. Then love waves come in third, and then finally the slowest of them is going to be the Raleigh waves. The least destructive of these different kinds of earthquake waves is your primaries, and then the most destructive is going to be the love waves. And now this is very important. Which kinds of waves can travel through a liquid? Okay, could be water, but it mainly anything that is in a liquid form. The P waves can travel through it, but S waves cannot. Okay, and then love waves, they cannot travel through a liquid, but Raleigh waves, they can. Okay, so just keep that in mind, because that's going to be very useful for knowing the different layers of the inside of the earth by using earthquake waves. Okay, we're going to take a break, and when we come back, we're going to talk about the speed of earthquake waves.